cosmos, space, and time travel, science and technology. Brought to you by theoretical physicist, futurist, popularizer of science, and world-renowned author, Professor Michio Kaku.
And GCNlive.com.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Every week on Science Fantastic, we profile some of the most amazing developments in science and technology. And today, we're going to blast off to Mars. That's right, there's an astounding new probe that's being readied by NASA. And we're going to put a helicopter, get this, a helicopter on another celestial body in the heavens. With us today is Professor Jim Bell of Arizona State University. He's the president of the Planetary Society and the author of a number of great books, including The Hubble Legacy, 30 Years of Discovery and Images, and The Ultimate Interplanetary Travel Guide, a futuristic journey through the cosmos. And if you want to know more about Science Fantastic, go to my website. It's mkaku.org. mkaku.org. We have about 3 million fans on Facebook, and I've written 4 New York Times bestsellers. The latest New York Times bestseller that I've written is called The Future of Humanity, talking about the possibility of one day, perhaps, terraforming Mars, mining the asteroid belt, and who knows, maybe one day even leaving the solar system. But today, let's focus on the moon, Mars, and beyond with Professor Jim Bell of Arizona State University, president of the Planetary Society, as we explore the universe. So, Jim, glad you could be on Science Fantastic.
Well, thank you for having me on the show. It's great. It's just such an exciting time in space exploration, right?
Yeah, that's right. Well, let me ask you a question about your youth. When you were a kid, what first steered you in the direction of science and then astronomy?
Oh, it's a great question. Really kind of two things. I grew up in the northeast of the U.S. in a relatively rural place that I was fortunate to have pretty dark skies on clear nights. And my family bought me a telescope, a small telescope, and so I was able to, see the cosmos myself, and with some other nerdy friends in school, we were able to, watch the planets and the moon and comets and nebulae, and just really experience the wonders of the universe, through my own eyes. And as a kid, that was just hugely inspirational and exciting, and asking all the questions that we do about what's going on out there. That was one thing. And the second thing, and this is pretty common among many of my colleagues in my generation. I'm kind of a middle-aged guy. Maybe it's common for you too. I was inspired by Carl Sagan and his 1980 show Cosmos, which you may remember back in 1980, there was very little science on television. There were only 3 major networks, and PBS was it. And here comes this guy with a distinctive guttural New York accent and a tweed jacket. This professor's talking about space and astronomy and the planets, and he wasn't using jargon and lingo. He was talking like plain English, and I could understand it. And of course, Sagan was a visionary, and it was hugely inspirational to me as a young person, and many others in my generation.
Okay, and now you are president of the Planetary Society. So tell us a little bit about what is the Planetary Society.
Yeah, and that's kind of ironic, because the Planetary Society was founded in 1980 by Carl Sagan and Bruce Murray and Lou Friedman as a response to proposed enormous government funding cuts for space exploration. And so we've been around for that entire time, 40-year anniversary this year of the Planetary Society. It's the world's largest.
Congratulations.
Yeah, thanks. It's the world's largest public space advocacy and education organization, membership organization. We've got more than 50,000 people in many, many countries around the world. And we focus on, getting people involved, making people around the world feel like and actually be part of exploring our solar system and beyond. So we work on education, we work on advocacy, we work on projects. It's just a great organization, and hopefully you've got a bunch of members out there who are listeners, and a lot of listeners who might want to become members. It's a great organization.
And speaking about exploring the cosmos, let's just say a few things about the moon. I understand that there's going to be a new drive to put humans back on the moon. We have Elon Musk of SpaceX. He's readying his version, the Falcon Heavy. We have NASA itself with the SLS booster rocket capable of going to the moon. Not to be outdone, we have Jeff Bezos of Amazon with his new Armstrong rocket, apparently capable of also going to the moon. And not to be left out, the Chinese have the Long March rocket, and they want to put their flag on the moon as well.
Right.
So do you think, therefore, that we could be entering a new era where it's actually now fashionable to go back into outer space?
Well, I don't know about fashionable, but certainly becoming more practical and more affordable, right? Especially with more of these entrepreneurial so-called new space companies getting involved in building rockets and the amazing things that are happening with SpaceX and Blue Origin in terms of their launch vehicles and many others. So access to low Earth orbit and near Earth space, including the lunar environment, is becoming easier. It's never going to be easy, right? It's never going to be easy to get in a rocket and go anywhere, but it's becoming easier and less expensive, and that opens up more opportunities for exploration, more opportunities for commercial development, etc. And the moon is our testing ground for deeper space operations. Everybody's understands that the next big goal for NASA astronauts is to go to Mars. Astronauts around the world and other space agencies as well. The first people to Mars coming up in our lifetimes, maybe within 10 or 20 years. And here we have the moon, and we went to the moon in the 60s with the Apollo program, and we lost that capability with the loss of the Saturn V, the shutdown of that program. And so that a lot of that's getting rebuilt, and it's a great place to practice deep space travel, deep space operations, relatively close to home, so safer than going out to Mars or asteroids. And it's also, there's some great science to do at the moon. The Apollo astronauts started that process, and learning about the moon teaches us about the origin of the Earth and the Earth-Moon system and other planets in our solar system. So it's a combination of just all kinds of factors, the technology, the more affordability, and the scientific goals that are pushing us to the moon and then on to Mars and beyond.
Well, you mentioned affordability, and back in 1966, I still remember that the Apollo budget to send us to the moon consumed 5% of the entire federal budget. Think about that. 5 cents of every dollar you paid in income tax went to the Apollo space program, and that was unsustainable. I mean, it cost $10,000 to put a pound of anything into near-Earth orbit. It cost about $100,000 to put a pound of anything on the moon, and it was unsustainable. But now we have reusable rockets, complements of Elon Musk and SpaceX. Some people think, therefore, that could really open up the heavens if the cost of booster rockets continues to drop, especially if they're reusable. What are your thoughts?
Yeah, no, absolutely.
Let's take a short commercial break, and after the break is On to Mars with the Perseverance Mars rover. Once again, our special guest today is Jim Bell, president of the Planetary Society. You are listening to Science Fantastic, and give us a call if you want to get on the air. The number to call is 612-564-8135. Welcome back to Science Fantastic with Professor Michio Kaku. And once again, if you want to ask a question and get on 100 radio stations that carry Science Fantastic, give us a call. The number to call is 612-564-8135. 8135. Leave your name, call letters to the radio station or website that you're calling from, and the city you're calling from, and bingo, maybe you can get on national radio. Well, once again, our special guest today is Professor Jim Bell of Arizona State University. He's the president of the Planetary Society, author of a number of great books, including The Hubble Legacy, 30 Years of Discovery and Images, and we're talking about Mars. So tell us a little bit about Mars Perseverance. I understand that NASA wants to put a helicopter on Mars. That would be a game changer, right?
Yeah.
Being able to roam over the surface of Mars like a helicopter. Could you elaborate?
Yeah, so Perseverance is NASA's next Mars rover. It's going to launch next month to Mars. We'll land in February at a place called Jezero Crater, which is a big hole in the ground with a spectacular river delta that flows into it. So it was a place where there was a long-lived lake environment early in the history of Mars. Pretty spectacular place to explore. And we'll be looking for signs of evidence of ancient life on Mars that might be preserved in that rock record. And we'll be collecting samples with the Perseverance rover through a coring drill, make cores of rock samples and scoop up soil samples, put them in these little containers that are about the size of a cigar tube, up to 40 or so of them, and put them on the surface for a future mission to Mars to return them to the Earth. So it's the first part of Mars sample return. Pretty exciting. The rover is made out of 90% spare parts from the Curiosity rover that's on Mars right now, that's been on Mars since 2012, operating great. And that was to save money, to keep the costs as low as possible. But lots of different components and instruments on this rover compared to Curiosity because of that sample return goal. And there's a couple of tech demos on the rover. One is the helicopter that you mentioned. It's about a 4-pound solar-powered drone, basically, with a double rotor blade system that the blades are about 4 feet across. So it's a pretty good-sized drone. And the idea is just to do some test flights. There's a camera on the drone, and the rover will drop off the helicopter, back away, and then the helicopter will do a series of test flights to demonstrate powered flight in the Martian atmosphere and take some pictures, etc. It's not going to be really used as a guide or a scout for the rover because it really has a very limited lifetime because this is the first test. But you're right. If it works really well and they can validate the engineering behind it, then this kind of technology could be on future missions to Mars or other places. In fact, NASA picked a quadcopter to go to Saturn's moon Titan later in the 2020s. So this kind of technology is going to be more and more common in planetary atmospheric exploration.
Now, the atmospheric density of Mars is only 1% that of the Earth, and helicopters, of course, require a lot of atmospheric density in order to get off the ground. So wasn't it an engineering challenge to be able to create and engineer a helicopter that can work in such a thin atmosphere, almost a vacuum?
Not really, actually. I mean, of course, it's an engineering challenge to build anything to go into space, but the gravity is lower, so that helps, and the helicopter is very light. It's only about 4 pounds. So, while it's not going to be possible to fly helicopters that can carry people like on the Earth because the atmosphere isn't thick enough, it is possible to launch small drones, to fly small aircraft, drone kind of aircraft that are light and with a good wingspan. So partly the reason the blades are 4 feet across is because the atmosphere is so thin. But it's very light, and they've actually demonstrated this in very large vacuum chambers on the Earth, pumping them down to the pressures of the Martian atmosphere and demonstrating that the helicopter should fly just fine.
Okay, and also you mentioned the fact that it's going to be collecting rocks for eventual rock retrieval. In other words, rocks from Mars will eventually come back to the planet Earth. Now, some people say, well, what's the big deal? Because meteors from Mars have actually landed on the Earth in the past. So could you elaborate, how is it that we know that Mars rocks in the form of meteors were blasted out of Mars and actually landed on the Earth?
Yeah, there's something like 50 or so samples that have been found, many on the ice in Antarctica of Mars rocks on the Earth, just like there are rocks from the moon on the Earth. You know, an asteroid or comet smashes into a planet like Mars or a planet like the moon and throws up a bunch of debris, and some of that finds its way to the Earth. And we know that those particular samples are from Mars because some of them have trapped atmospheric bubbles in them that match the atmosphere of Mars. What we don't know is where are they from. So we don't have any context, the geologic context, what kind of environment were they in, et cetera. They're kind of random samples, not even from the surface in most cases, but dug up from deep in the subsurface by the impact event. So we want samples that are well chosen by geologists and others through the rover of surface areas where we believe that water has flowed for long periods of time, sediments have been transported, maybe evidence of past biologic activity has been preserved in the chemistry, in the mineralogy, maybe even fossils, extremely low probability. We don't really believe that we'll find fossils. I mean, when you look at ancient rocks on the Earth that are 3-4 billion years old, this is well before organisms were forming fossils or forming hard shells on the Earth. So the evidence for early life on Earth is chemical, textural, mineralogic, isotopic, and we expect that might be the same case on Mars. So that's partly why we need to bring those samples back, too. We really want to study them in detail in the best laboratories on the Earth, because we can't transport those amazingly detailed, precise lab instruments, some of which are the size of, entire rooms. We can't get those to places like Mars yet, so we need to bring the samples back.
Now, some astronomers have speculated that our solar system is sort of like a gigantic ping-pong game, because asteroids plow into Mars and blow rocks into space containing maybe DNA, who knows for sure. These rocks then land on the Earth. And therefore, we should also have Venusian meteors, lunar meteors, as well as Martian meteors. And they, in turn, probably had Earth rocks that landed on their terrain as well. And so some people have speculated that there could be a ping-pong game between Mars, Earth, Venus, and the Moon, sharing different rock samples of which maybe DNA is a component. But this is a theory, of course. What are your thoughts?
Well, it's a hypothesis that is very, very difficult to test. Can life or complex organic molecules even survive those kinds of impact processes? Yeah, some scientists think so, others think not. There are experiments that are going on trying to look at the viability of terrestrial kinds of organic molecules under typical impact conditions. But you're right, and this idea goes back a century. The idea of panspermia, that the cosmos is seeded with life. It doesn't really solve the problem of where did life come from, right? I mean, if Earth life came from Mars, for example, where did Mars life come from? Well, maybe it came from somewhere else. Well, where did that life come? So we're still driven to try to find the answer. How did it all start, as well as are we alone?
Now, journalists obey the rule, follow the money. And astronomers apparently follow the rule, follow the water. And I understand that, most water on Mars is frozen. It's a very cold, frozen desert. However, underneath the ice caps, there's speculation that there could be liquid water lakes. So could you elaborate on the possibility that perhaps below the surface there could be deposits of liquid water?
Yeah, it's extremely likely. Mars is a terrestrial planet like the Earth, though smaller. So it gets warm as you go down because of internal heat sources. The core it may not be molten anymore because the planet doesn't have a magnetic field, but it was molten early in the planet's history, and it's still cooling.
Okay, Jim, let's take another short commercial break, and after the break, we're going to continue a discussion of exploring the solar system. Once again, Jim Bell is president of the Planetary Society. Welcome back to Science Fantastic with Professor Michio Kaku, and this hour we're getting ready to go back to the planet Mars with the Mars Perseverance probe ready to go. It will have rock retrieval capabilities and a helicopter that could zoom over the surface of Mars. Now, Mars is still a mystery. There's so many things we don't know about the planet. For example, methane. Methane gas is found in your kitchen. It's a byproduct of decaying organic materials as well as chemical processes. But methane deposits have been found on Mars, and we are clueless to understand where they come from. So could you elaborate about the mystery of where is the methane coming from?
Well, first of all, it's a hypothesis that methane is on Mars. It's not been proven. There's extremely tiny amounts that have been detected in some measurements and not detected in other measurements. So it's really an enigma, and the scientific community that studies the Martian atmosphere and the Martian environment is in the middle of a really kind of a debate about whether the measurements are valid, whether we're seeing, for example, contamination from the rover on the ground making the measurement, whether we're just seeing uncertainty in the measurements, or whether we are actually detecting methane. But tiny, parts per billion amounts, really tiny amounts. And the European orbiter, which got to Mars recently, called the Trace Gas Orbiter from the European Space Agency, has a very sensitive instrument that's designed to detect methane in small amounts on Mars, and they haven't detected any. So lots of conflicting data. This is a great example of, the scientific community is in the middle of a big forensic mystery. Some evidence this way, some evidence that way, and like forensics, it's going to take more clues, more evidence to tip the scales and the hypotheses one way or the other. So I wouldn't phrase it as strongly as you did.
And also, when you look at photographs of the surface of Mars, you see the remnants of what looks like to be riverbeds, seas. Some people even think that maybe there was an ocean the size of the United States once upon a time on Mars, but they're all gone. So here's the question. What happened to all the water on Mars?
Yeah, you're right. This is, one of the most amazing discoveries of the last few decades of Mars exploration is all that evidence that Mars was much more like the Earth early in its history. A thicker atmosphere, warmer temperatures, liquid water flowing on the surface, rivers, lakes, gullies, etc. Where did it all go? NASA and other space agencies are trying to figure that out. The leading hypothesis is that early in the history of Mars, when the core was molten and the planet had a magnetic field and a thicker atmosphere, it was protected from the constant barrage of high energy particles from the solar wind, which can sort of slowly, like billiard balls, blast the atmosphere away over time. But the magnetic field protects a planet from that process. The Earth's magnetic field protects our atmosphere from much of that process. And then when the core of Mars cooled, because it's a smaller planet, so the core cools faster than the Earth's core, and that magnetic field got shut off, then all of a sudden, 2-3 billion years ago, the solar wind can directly impact the upper atmosphere and drive off those molecules and break down those molecules. And it's a slow process, but it's had billions of years, and over time, the atmosphere gets thinner and thinner and thinner. And
okay, Jim, we have to take yet another short commercial break. But after the break, we're going to continue a discussion of exploring the solar system and mining the asteroid belt. Is that a possibility? Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Professor Jim Bell of Arizona State University. He's the president of the Planetary Society and the author of a number of great books, including The Hubble Legacy, 30 Years of Discovery and Images. And so we're talking about exploring the solar system. And, of course, one possibility that people have looked at over the last several centuries is the possibility of life on Mars. In fact, Carl Sagan, when he was a teenager, used to read the John Carter of Mars fiction, science fiction, and he was hooked. He thought that maybe one day he or his descendants would be able to roam over the sands of Mars and chase after Dejathosaurus. Well, we have now doubts about all that. But, well, what are your thoughts? Any possibility that life could thrive on Mars, or maybe in the past? Or is it simply a science fiction and fantasy?
Yeah, I mean, Mars is the most Earth-like place in our solar system besides the Earth itself, and so it's been a focus of speculation in science fiction and science itself in terms of life. And what we've learned in the past 50 years of exploring Mars with robotic probes is that the surface itself is an extremely harsh environment today. Much colder, much thinner atmosphere, no protective ozone layers, so lots of harsh ultraviolet radiation hitting the surface. So very, very a dangerous and inhospitable environment for life as we know it, including people someday when we go there. We're going to have to protect ourselves against all of these things. But two things. One, if you go back in time, turn the clock back to when Mars had that thicker atmosphere, when it was much more Earth-like, although never really like the Earth, but much more Earth-like, then it was a habitable environment. There's water flowing on the surface, organic molecules, heat sources from volcanoes, impacts, and geothermal. These are what we need for life to have existed and thrived on the Earth. So the conditions were right, and that's why we go look at those ancient places like where the Perseverance rover is going. And secondly, if you just go down into the subsurface today, deep into the subsurface, maybe meters, tens of meters, kilometers, you protect yourself from the ultraviolet radiation. It gets warmer as you go down, and much of that ice that we see all over the planet in the near surface and on the surface could be melted, and there could be aquifers and underground water, which would be great environments for life on Mars even today. Simple life, microbial life. There's enormous volumes of microbial life on the Earth in the subsurface in those kinds of places. And what we've learned is it's not crazy to speculate that life could exist on Mars in those kinds of environments even today.
Okay, and also terraforming Mars has been a goal of the Mars Society, for example, and we've had them on the show. Even Elon Musk speculated that what happens if you detonate a few hydrogen bombs on the polar ice caps, you could melt the polar ice caps and water would flow on the surface of Mars again. Well, of course, the water would be radioactive, and I'm not sure you would want to drink it. Other people have proposed that far in the future, maybe solar satellites can melt the ice by beaming sunlight to the polar ice caps, thickening the atmosphere, allowing water to flow freely as a liquid on the surface of Mars. But of course, all this is pure speculation. But what are your thoughts?
Well, this is... I tend to be a pragmatist. While it's fun to speculate about the future, topics like terraforming are, while possible and imaginable to do planetary scale engineering like that, they're in the far future. They're centuries to millennia in the future to turn an entire planetary environment like Mars into a more hospitable Earth-like environment. So I think, but in order to do that, we're really going to have to understand the environment that is there on the planet today. We're going to have to understand the potential resources that are there on Mars, how much water is trapped in the subsurface, how easy is it to extract oxygen from the atmosphere, what is the inventory of organic molecules on that planet. And we're starting that process with robotic probes, and it's going to take people to really get the answers in the decades ahead.
Okay, well, let's take another short commercial break. You are listening to Science Fantastic with Professor Michio Kaku. After the break, let's go on to the asteroid belt and beyond. Is it possible to mine the asteroids? Is there another gold rush out there in outer space? And again, if you want to get on Science Fantastic, give us a call at 612-564-8135. And maybe you can get on 100 radio stations that carry Science Fantastic. Welcome back to Science Fantastic with Professor Michio Kaku. With us today is Professor Jim Bell, President of the Planetary Society and a professor at Arizona State University. And we're talking about exploring the solar system. Now, we mentioned before that billionaires are opening up their checkbooks and helping to sponsor some of these fantastic devices through SpaceX and Blue Origins. However, Google billionaires also want to jump in the game, and Google billionaires have been sponsoring the idea of mining the asteroid belt. Now, remember that when Thomas Jefferson, years ago, signed the Louisiana Purchase, he speculated that it would take 1,000 years to colonize the Louisiana Purchase. However, what happened? Gold was discovered in California, and bingo, all of a sudden the West was colonized within less than 100 years. And so some people think there could be another gold mine out there. Platinum-based metals, rare earth metals could be mined. And NASA at one point even had a mission to retrieve an asteroid. But, well, what are your thoughts about mining the asteroid belt and letting that pay for the bills?
Again, my thoughts are much more pragmatic than futuristic thinking about precious metal mining. These objects have very little gravity, so mining as we understand it really won't work, and so an entire new technology is going to have to get built, and that's going to take time. But while precious metals will be interesting at some point in the far future, I believe that the reason to extract resources from asteroids or other places in space is for use in space at those places and not really to bring that stuff back to the Earth. For example, the gold of the solar system is not going to be gold or platinum or other precious elements in the near future. It's going to be water ice. Water ice is, you can extract oxygen for us to breathe. You can extract hydrogen and oxygen to use as rocket fuel. You can use it as a shield against radioactivity. Enormous numbers of uses and practical uses for humans out there in the solar system. So I think looking for water on asteroids or water in the polar craters of the moon, places like that, water in the subsurface of Mars, that's the prospecting and mining activity that's going to dominate the next many decades and near future of exploring space and sending people into space.
Now, moving on, we have the moons of Jupiter and Saturn. Titan is an intriguing moon because it seems to have an atmosphere and possibly methane and ethane. And some people have speculated, and this is speculation, that in the future we'll use Titan as a gas station. We'll load up on methane by landing on Titan. Of course, you also need an oxidizer because you have to have a chemical reaction to stimulate it. But what are your thoughts about exploring the moons of Jupiter and Saturn?
Yeah, they're fascinating worlds out there, planets in their own right. Europa, the moon of Jupiter, has an enormous subsurface ocean that has more volume than all the oceans on the Earth, for example. Titan, it's known to have ethane, methane, propane in its atmosphere. It's not hypothesized, it's known, it's been measured. We've sent probes to the surface to measure it directly. So it's very much like what the early Earth's atmosphere was like before oxygen took over and completely changed the nature of our atmosphere and of life on our planet. So lots of great science reasons to go out there, but also great astrobiology reasons to understand the early history of the evolution of terrestrial worlds like those, cold terrestrial worlds, but certainly planets in their own right with cores, mantles, crusts, interesting geologic histories, and in the case of Titan, the thickest atmosphere of any moon in the solar system, 1.5 times thicker than Earth's atmosphere. So, yeah, fascinating worlds, tough to get to, takes a long time. They're harsh environments. The radiation around Jupiter, for example, extremely harsh environment, so lots of technical and engineering problems, but also those places are calling to us to understand the history of life and places that could still harbor life in our solar system.
Well, what's also the progress of a NASA probe to Europa to send a submarine? a submarine under the ice cover into the liquid water ocean of a moon of Jupiter. How's that coming along? I understand that at one point it was canceled and then delayed.
Well, it's
but
never
what are your
been.
Thoughts?
Yeah, it never officially has been started. It's all speculation and laboratory studies right now. What is happening is a mission will be launched called Europa Clipper. Will be launched later this decade to orbit Jupiter and fly by very close by Europa many, many times and map the surface at high resolution. We don't have a high resolution map of its surface, so we really don't know where to land a lander to drill into that ice. So the first thing that has to happen this decade is building up that detailed map of the geology and understanding the history of Europa, and then figure out where to land. And then maybe in the 2030s, we'll send a lander and really get down onto the surface, characterize that environment well, figure out how hard or easy is it really to drill into that ice. And the idea of a submarine or other submersible, I think, is many, many decades ahead, and certainly nothing official has been started.
Now, some scientists have speculated, and this, of course, is pure speculation, that because the moons of Jupiter and Saturn are more plentiful than Mars and Earth, that throughout the galaxy, perhaps, and this is, of course, a big perhaps, aquatic life forms are more common than terrestrial life forms. And perhaps we are therefore, we're the oddballs, we're the minority, that most of the universe, if there is life, is aquatic. Well, unfortunately, we have to end on that note.
Let's go find out.
Yeah. Once again, our special guest today has been Professor Jim Bell, President of the Planetary Society, Professor at Arizona State University, author of The Hubble Legacy and The Ultimate Interplanetary Travel Guide. And you've been listening to Science Fantastic with Professor Michio Kaku. Give us a call, and you can get on 100 radio stations that carry the show. The number to call is 612-564-8135. Leave your name, call letters of the radio station or the website you're listening to, and the city you're calling from, and then ask away. Ask that question that you've always wanted to ask to a scientist. Welcome back to Science Fantastic with Professor Michio Kaku, Professor of Physics at the City College and also the Graduate Center of the City University of New York. And on Science Fantastic today, we're going to throw the lines open because this hour is your hour. This is the time when you can get to the phones and call that magic number, 612-564-8135. Write that number down, 612-564-8135. And in this hour, all we are asking of you is that you leave your name, the call letters of the radio station you're listening to, or the website, and the city you're calling from, and bingo, maybe you can be on almost 100 radio stations that carry Science Fantastic. So once again, give us a call if you're curious about this great world of ours, 612-564-8135. And if you want to know more about what I do for a living, then go to my website, mkaku.org, mkaku.org, or to my Facebook site at Michio Kaku, or Twitter at Michio Kaku. And also on Facebook, we have 3 million fans on Facebook. On Twitter, we have about 1 million people per week who get the tweets that I send on Twitter. And I'm on a book tour, and maybe I'll be speaking in a city next to you, signing your copy of my latest New York Times bestseller, The Future of Humanity. Go to my website, mkaku.org, mkaku.org, and maybe, just maybe, I'll be signing your copy of The Future of Humanity. And after I sign your book, well, you can go to eBay and auction it off for money. That's right. You can actually make money by going to the book tour. Also, check out my other New York Times bestsellers. I have 4 of them altogether. One of them is called The Physics of the Future, talking about robots, artificial intelligence, health, cancer research, talking about how we will live in the next 50 to 100 years. And then in physics of the impossible, I go, 500 years into the future, when we might even entertain time travel. We might even have teleportation, starships within that frame of time. And then my book, The Future of the Mind, I talk about the incredible developments about inner space, not just outer space, but probing into the inner thoughts of the human brain. Did you know that by looking at blood flow in the brain, we can actually see how thoughts are created? This is amazing. And some old wives' tales that scientists and the average person believe, but never could be verified, can now be tested. For example, it's an old wives' tale that says that when a man talks to a pretty girl, he starts to act stupid. Now, we've all seen that effect, but we can now see it at the level of blood flow in the living brain. Yes, when a man talks to a pretty girl, chances are blood drains from the prefrontal cortex, and the man starts to act mentally retarded. Amazing. We can quantify this effect. We can actually introduce metrics to measure blood flow and show that, yes, sometimes common sense and old wives' tales are correct. Well, that's all in my book, The Future of the Mind. But the latest book is called The Future of Humanity, where I go thousands of years into the future. You know that next year we're going back to the moon. Did you know that? After a 50-year gap, we're going to send an unmanned space probe to orbit around the moon. After that, within about maybe 5 years or so, we're going back to the moon with astronauts. In fact, we may even have a traffic jam around the moon because, one, we have NASA with the SLS booster rocket. Two, we have Elon Musk of SpaceX with the Falcon Heavy rocket. It's a moon rocket. Three, we have Jeff Bezos, formerly the richest man in the world, and he has his own spaceport called Blue Origin's rocket program in Texas, and he's planning to launch the new Armstrong rocket, which can go to the moon. And, not to be outdone, the Chinese. The Chinese have the Long March rocket, and they want to put the Chinese flag on the moon as well. So we could have a traffic jam around the moon within the next 5 years. Well, anyway, find out what all the excitement is about by going to my website, mkaku.org. mkaku.org. Well, without further ado now, let's go to the phone calls. And once again, the number to call is 612-564-8135. So let's take the first listener phone call.
Stu, KFQD, Muldoon, Alaska. Professor Kaku, I'm making this call in late February, and the radio signal has been lost, or the satellite signal. The announcer on the radio says this time of year, the sun, solar flares, sometimes interrupts with the transmission. Could you please explain why it's seasonal? Thank you.
Yes. Well, it turns out that the solar flares are actually caused mainly by sunspots on the sun, and they go through an 11-year cycle. And so in this 11-year cycle, the sunspot activity peaks and then drops down tremendously. Now, why is that? Because magnetic field lines are like the windings of a clock. When you wind up a clock, the mainspring tightens up, and then if you release it, it goes boing when you release the mainspring of a manually wound up clock. Now, it turns out that the sun rotates, and the magnetic field lines, however, do not rotate in synchronization with the sun. So as the sun rotates, the magnetic field lines do not rotate in synchronization. There's a mismatch. And so just like winding the mainspring of a clock, it winds up the magnetic field lines until one day the field lines are suddenly released, and you get this explosion of activity every 11 years. And then it is also seasonal because we know that the Earth, for example, the North Pole points toward the sun during wintertime. In fact, that's why we have winter. The Earth tilts at 23 degrees. Therefore, the North Pole tilts toward the sun during summertime, so it gets hotter. And then Australia has the opposite pattern. Its south pole points away from the sun, and therefore sunspot activity is seasonal as well as having its 11-year cycles. So there are actually 2 cycles within the sunspot. And then we now realize that on a scale of several hundred years, the sun has an explosion, and a tremendous, gigantic solar flare can actually hit the Earth, like what it did in 1859. That's called the Carrington event. Now, the Carrington event, if it were to happen today, would cause massive blackouts over the entire world. Property damage, perhaps $2 trillion. Satellites would be knocked out. Our astronauts in outer space would be endangered. Power plants on the Earth would be short-circuited. We would have blackouts throughout the Earth. And, of course, our satellites would be partially destroyed as a consequence. Now, we don't know how often the Carrington event takes place. But going to the North Pole, we can have evidence that perhaps it happens every 200 or so years. Okay, well, let's take a short commercial break. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, if you want to be part of the March of Science, if you want to get on almost 100 radio stations which carry Science Fantastic, then give us a call. The number is 612-564-8135. Okay, let's move on now and take the next listener phone call.
Good afternoon, Doctor. This is Edwin. I'm calling you from Dallas, Texas, and I'm listening to you via your website. My question is there a way to supply energy to the world by having solar panels in space, acres upon acres of solar panels in space, and maybe drones delivering fully charged batteries down to Earth? Do you think it is possible, and when will it be done? Thank you.
Well, solar power from outer space is possible. In fact, I write about it in my book, The Future of Humanity. However, the problem is economics. The problem is how cheaply can you extract energy from outer space. First of all, you lose energy when you go through the atmosphere. You lose roughly 50-60% of the energy going through the atmosphere. But even then, if you have a large solar panel in outer space, big enough, large enough to encapsulate tremendous amounts of solar energy, you can convert it to microwave radiation and beam the microwave radiation back down to Earth. However, there are problems. First of all, satellites go around the Earth every 90 minutes or so. Therefore, if you have a satellite that's very close to the Earth, maybe a few hundred miles from the Earth, you have to have hundreds, thousands of them in order to beam down a continuous amount of energy. In fact, that is one of the problems with a Star Wars program, where you want to shoot down missiles that are being launched, let's say, from Russia. The problem is, at any given time, you want to have a satellite go overhead, which means you have to have thousands of satellites going overhead. Now, the solution to that is to make them geostationary, which means a satellite has to be about 20,000 miles, not a few hundred, 20,000 miles in outer space. And that's how satellite TV dishes work. Satellite TV dishes work because the satellites are, quote, stationary. They rotate at the same rate at which the Earth rotates around its own axis. But the problem is you lose a lot of energy in the process because the solar panel is 20,000 miles from the Earth. So in other words, is it possible? Yes. Is it economically feasible? Well, that's the killer. We want to reduce the cost down to the point where it's competitive with ordinary solar that you get by simply putting a solar panel in your backyard. Now, there's also the concern of safety as well, because we are talking about beaming large quantities, industrial quantities, in fact, of microwave radiation from outer space. So we have to make sure there are fail-safe systems to make sure that the thing doesn't go out of control and in the process not exactly become a death ray, but in the process cause damage to the surrounding areas if the satellite starts to wander and the beam is not totally stationary. So once again, is it possible? Yes. Is it compatible with the laws of physics? Yes. The question is economics. Can you compete with oil, coal, and ordinary solar? At the present time, launch costs are too expensive to do this, but as we have reusable rockets entering the economic equation, costs could drop to the point where it becomes feasible. Now, for Mars, people have thought that this is the ideal way to melt the polar ice caps of Mars, and then liquid water will flow freely on the riverbeds, the ancient riverbeds of Mars. So this is being thought about not just for the Earth, but also for the planet Mars. Okay, let's move on now to the next listener phone call.
My name is Pam. I'm listening to KSIM, KZIM, out of Cape Girardeau, Missouri. When recently listening to an Art Bell program from 1997, he mentioned your name, that in that year, going against conventional theory that there are 5 dimensions, you believed there were 10. My question is, do you still believe that? Thank you.
Well, yes, I've been on the Art Bell show several times talking about hyperspace. In fact, I have a bestseller called Hyperspace, where we no longer necessarily believe that we live in a 3-dimensional space-time world, or 4-dimensional if you add time. We believe that there could be higher dimensions all the way up to 10, possibly even 11. This theory is called string theory, and we think that it is the fabled theory that eluded Einstein for the last 30 years of his life. He was chasing after a theory of everything. Now, we believe that in 3 dimensions, you cannot cram all the forces into one single theory. 3 dimensions is too small to accommodate the nuclear force, the electromagnetic force, and the gravitational force. When you start to go to 10 dimensions, all the forces fit very neatly into a single theory called string theory. In fact, that's what I do for a living. And if you go to any physics department, go to any physics conference, then yes, they'll make mention of string theory because it dominates the field. Some people say, well, what's the alternative to string theory? And the answer is, there are none. It is the only game in town. It is the only theory which can unify gravity with the quantum theory. These are the 2 great theories of the universe. The quantum theory gives us a theory of atoms. The theory of Einstein, theory of gravity, gives us a theory of black holes and expanding universes. These 2 theories don't like each other. So far, it has resisted almost all attempts to unify the 2 into a single theory. So far, string theory is the only candidate that has survived. Now, can we test it? That's the problem. The Large Hadron Collider outside Geneva, Switzerland, is simply not powerful enough to totally verify string theory. That's why many nations of the world want to go to a new generation of particle accelerators, even bigger than the one in Geneva, Switzerland. For example, the Japanese are looking at the ILC, the International Linear Collider. The Chinese are jumping into the game. They've made a proposal for a super atom smasher. And in Geneva, Switzerland, the European Union has proposed a successor to the Large Hadron Collider. So once again, it is the leading candidate. String theory is the leading and only candidate for a theory of everything. It's a theory defined in 10 dimensions where we have enough room to put all the forces of nature, but has it been tested? And the answer is no. It may take many more years before we have a test of string theory. Sorry about that. Okay, well, let's move on to the next listener phone call.
Raymond Cronin. I download your talk show on YouTube. Calling from Cadiz, Kentucky, and my question is this. I was listening to Stephen Hawking not too long ago, and he was saying that when he adopted the Euclidean approach to the beginning of the universe, I'm assuming that's the geometry. I'm wondering what the hyperbolic approach would show if it's ever been attempted. Thank you.
Well, you ask a very interesting question about the late Stephen Hawking, who was a pioneer in understanding the Big Bang theory and also black holes. Now, he had several theories. One theory was that black holes are not really black, they're gray. They emit something called Hawking radiation. That's his main achievement, Hawking radiation. However, that's also the reason why he probably never won the Nobel Prize in physics. I speculate, but the Nobel Prize Committee only gives Nobel Prizes for theories that have been proven experimentally. And Hawking radiation is so faint, so small, that we have never directly measured it, even though we all believe that it's there. He had another theory about time, and that is, did the universe begin at some instant of time? That is called Minkowski space. He introduced something called Euclidean space. So let's take a short commercial break, and after that, we'll talk about whether or not you can have a universe with no beginning. That was his theory. Okay, you're listening to Science Fantastic. Give us a call. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, if you want to get on air and ask a question about science, give us a call. The hotline number is 612-564-8135. Well, the question that was asked before the break was the question about the legacy of Stephen Hawking, that he had a rather unusual theory about time itself. Hawking realized that there is a problem with the Big Bang, and that is everything suddenly started at some instant of time, and he even believed that that was the reason why there's no God. In other words, it has theological implications because he said there was no time. There was no time for God to create a universe because the universe was born at the beginning of time with a Big Bang. So Stephen Hawking tried to modify this. He said, for example, take a balloon. If you take a balloon and you're an ant on the balloon, and the question is, can you go above the North Pole? No. If you're wandering on the surface of a balloon, the North Pole is there, but you cannot leave the balloon. And so he thought that the universe of time was like a balloon, that if you go to what is called Euclidean time, that time is not in a straight line. Time is like a balloon, and a balloon has no beginning. And therefore he said, aha, that explains how the Big Bang had, in some sense, no beginning. Well, let me say that that's not the point of view that other physicists who work in the quantum theory believe. Many people who work in the quantum theory lean toward the multiverse idea, that our universe, well, is a bubble, but there are other bubbles out there. And our bubble did begin in a Big Bang. But since there are other bubbles, there are other parallel universes. This is called the multiverse theory. It is, in fact, one of the dominant theories in something called quantum cosmology. It's something that I work in, for example. And it goes around Hawking's disproof of the existence of God. Because Hawking believed there was no God because there was no time for God to create the universe. But you see, if universes are being created constantly, then that proof, the disproof of Stephen Hawking, goes out the window. Now, what is the thinking of scientists today about Euclidean time? The jury is still out. Because at the present time, there is no one theory that explains the instant of creation. The Big Bang theory does not tell you why it banged, how it banged. The Big Bang Theory simply says there was a bang. To understand why it banged, you need a higher theory, and that gets us back to string theory. String theory says that bangs happen all the time. Big bangs are happening even as we speak. Universes are being created. That is now one of the dominant theories of the creation of the universe. And if you want to find out more about this, get a copy of my book, Parallel Worlds, which talks about the multiverse theory. Okay, let's move on now to the next listener phone call.
Hi, Professor. This is Gary. I listen on the web, and I'm calling from San Rafael, California. I have a question about prime numbers and how they relate to cryptography somehow, and how generating keys and so forth. And I'm wondering why, like, people are getting cryptocurrency for calculating factors, numbers that can be factored into primes and so forth, and why some supercomputer can't just do that instantly. But basically just how prime numbers relate to keys and cryptography and such. Thank you very much.
Wow, you ask about 3 or 4 different questions in one question. So let's try to break it down. Let's take a short commercial break. And after the break, we're going to continue with Science Fantastic with Professor Michio Kaku. Welcome back to Science Fantastic with Professor Michio Kaku. The lines are open. You can give us a call or get on the web and ask a question or make a comment. The number to call is 612-564-8135. All we ask is that you leave your name, call letter to the radio station or the website, and the city you're calling from, and maybe you can get on almost 100 radio stations that carry Science Fantastic. Well, before the break, we had a very interesting call that mentioned several buzzwords. So let's try to break down these buzzwords one at a time. First of all, there's a question of code breaking, and that's called cryptography. And code breaking is sometimes based on factorizing a number. For example, if I give you a number with 1 million digits, think about that, a number with 1 million digits, and then I ask you to factorize it. That is, see whether it's divisible by 2, 3, 4, or 5. See if you can factorize it into 2 separate smaller numbers. Why, that would take centuries, even with a supercomputer. Supercomputers, even though they're very fast, have limits. And one of the limits is cryptography when you try to crack codes. That's why many nations use codes based on the ability to factorize a very large number. And if you have a number, let's say, with 1 million digits, to factorize it would require centuries of time on a supercomputer. So that's why prime numbers, which cannot be broken down, are of very much interest to the CIA and governments around the world. Then we have cryptocurrencies, which are different. Let me explain that. We have things that are cyber money. And cyber money out there is outside the realm of the jurisdiction of many nations. One nation does not control the internet. And so we have cryptocurrency like bitcoins that can flourish without national jurisdiction. Now, personally, I think it's a bad idea to invest money in cryptocurrencies, even though they are outside the jurisdiction of many countries. Therefore, tax laws do not apply to cryptocurrencies. First of all, criminals are very much interested in that because they want to launder money outside the jurisdiction and eyes of the major powers. However, it is gambling. And as a consequence, it goes up and down, up and down. Now, you may say to yourself, no, wait a minute. The stock market is also gambling. Some people call it a big, gigantic slot machine, which is the stock market. So the stock market is really the slot market, some people say. But you see, there is a difference there. Cryptocurrencies invest in nothing tangible. They provide nothing of value or use for society. The stock market, on the other hand, has many aspects of a slot machine. However, it invests in things that are good for society. Goods, services are speculated upon. And that promotes growth, innovation, wealth, progress. So there is a difference between Bitcoin, cryptocurrency on one hand, which produces nothing of real value, and the stock market, which is also a form of gambling, which does create a form of value. That is, it creates things that are useful for society. And then the next thing that was mentioned was the question of quantum cryptography. It turns out that a digital computer may take centuries to crack codes using ordinary numbers and prime numbers. But quantum computers can conceivably crack codes in an instant of time, codes that no nation can break with present-day technology. Now, we know because of all the WikiLeaks that have been released to the public, we know that the CIA has in fact looked into quantum computers to see whether they can crack codes of nations, because that, of course, would topple the secrecy of many a nation around the planet Earth. But the CIA concluded, as many physicists have concluded, that quantum computers are still decades away. We don't even know whether they're fully functional. However, quantum computers on a small scale have already been created. But a quantum computer that can compete with a digital computer still has not been created. Well, okay, let's take another short commercial break. Once again, you are listening to Science Fantastic. Give us a call at 612-564-8135, and maybe you can be part of the March of Science.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. Once again, the lines are open. You can always give us a call at 612-564-8135. Or you can go to my website and be part of Science Fantastic. The website is mkaku.org, mkaku.org. So find out what all the excitement is about. Well, we last left off, we had a question about cryptography. We had a question about quantum cryptography, cryptocurrencies, everything. And it turns out that's a very hot topic. So let me summarize really quickly what it's all about. First of all, cryptocurrencies like Bitcoin, I would not advise you to gamble on it because it is gambling. You could lose a fortune that way or gain a fortune, but you're not doing anything useful for society. Second of all, the CIA has in fact been interested in quantum cryptography because you can crack any code using a quantum computer. The catch? Quantum computers that are more powerful than digital computers do not exist yet. The slightest disturbance, somebody sneezing a block away, will cause decoherence to take place. All of a sudden, the atoms are no longer vibrating in unison, and the whole thing collapses. So decoherence, that is the fact that impurities, impure sounds and vibrations can destroy everything, that problem has not yet been solved. Okay, let's move on now to the next listener phone call.
My name is Stephen. I'm calling from Atlanta, and I listen on your podcast. My question is, I understand Caltech scientists have been able to move objects using light. They plan to one day scale this to move spaceships. A, how will they scale this to move something so large? B, how will they get light into space? And C, wouldn't it be better to get robots to go in this spaceship and have the spaceship be able to return rather than send humans? Thank you, and have a great day.
Well, you asked several things in one question, so let's try to break it down. First of all, is it better to send robots into outer space than humans? And the answer is, well, it depends. For space shots that go way beyond the orbit of the moon, that go to Jupiter and Saturn beyond, you really do want to have robots and not humans. Humans, we realize, are quite frail, and humans really have not gone much beyond the orbit of the moon. When we went to the moon 50 years ago, that was the world's record. We have not gone beyond the moon since that period of time. And it's very dangerous out there with radiation. Plus, of course, robots do not complain. They need no life support. They're relatively cheap, and they don't have to come back. In fact, many nations can send probes to the moon. Going to the moon is no big problem. The problem with sending humans to the moon is bringing them back. Only great nations have the capability of bringing back humans from the moon. So sometimes when conspiracy theorists say that we have not been to the moon because that requires a very advanced technology, realize that in principle, North Korea could probably send a probe to the moon. So going to the moon is not such a big deal. It's bringing astronauts back from the moon, back from outer space. That requires a very high level of technology. And so for short-term visits beyond Mars, going to Jupiter and Saturn, that requires robots because it's simply too dangerous to put humans out there, and is very costly because of life support. Life support easily can double, triple, quadruple the cost of a space mission. And humans, however, for short durations and for going to the moon and Mars, humans can do a much better job than robots. Robots, for example, cannot pick up garbage. Robots cannot even do simple tasks like repairing a broken toilet, or being a sanitation worker, or solving a crime. Blue-collar work on the planet Earth is better done with humans rather than with robots, because we forget that robots are adding machines. Adding machines, things that are repetitive, things that involve number crunching. That's where robots excel. But humans excel at almost everything else. We are innovative, we're creative, we have manual dexterity, we can recognize objects, we can run, jump. Robots cannot do any of the above, except with tremendous difficulty. For example, our most advanced robots can barely walk across the room, avoiding obstacles as they do that. And so, with regards to sending humans, with regards to sending robots to outer space, it depends on what mission you're talking about. Okay, let's move on to the next listener phone call.
Rodney Huffbeck, KNIS Radio, Redwood Falls, Minnesota. My question is, I understand matter is not destroyed or created. I believe God created the heavens and the earth because here's the question. The Big Bang Theory, well, if God didn't create the matter that caused the Big Bang Theory, well, I believe he created the matter that caused the Big Bang Theory. What else would explain that? Thank you.
Well, I see that our time is up. Once again, you've been listening to Science Fantastic with Professor Michio Kaku. And once again, if you want to be part of the March of Science, if you want to be part of the majesty and the splendor of the universe of ours, then give us a call at 612-564-8135. Leave your name, call letter to the radio station, and the city you're calling from, and hey, maybe you can get on almost 100 radio stations that carry Science Fantastic.
Brought to you by theoretical physicist, futurist, popularizer of science, and world-renowned author, Professor Michio Kaku.
And GCNlive.com.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. On Science Fantastic, we profile the amazing, jaw-dropping scientific discoveries which are revolutionizing our world and touching our lives. Now, normally, we open the lines and take your listener phone calls. If you call 612 564-8135. Yes, if you leave your name, the call letters of the radio station you're listening to, and the city you're calling from, then perhaps your thoughts will be heard on national radio. But some of you are kind of gun-shy and would rather simply type out a question. That's fine too. So in this hour, we're going to take the questions that you email me. Specifically, we're going to talk about time travel paradoxes. How do you resolve all those delicious paradoxes that you see in the movies? And robots. Are they dangerous? Are they going to take your job away? What jobs should you look forward to if you are a college student and you're fearful that a computer will take your job? And then we're going to talk about the brain, the mind. Was Sigmund Freud all washed up? Sigmund Freud had all these cockamamie ideas about sex and the unconscious mind. But hey, some of his ideas weren't totally wacko now that we can peer into the living brain. And dreams. Why do we dream? What is the meaning of dreams? And what does science say about people who can control their dreams, lucid dreamers? These are just some of the concepts we'll be talking about in this hour on Science Fantastic as we answer your emails. And once again, if you want to send me an email, go to my website, mkaku.org. I've written 4 New York Times bestsellers, and you can find out what my tour schedule is, and maybe I'll be coming to a city next to you, signing your copy of The Future of Humanity, my latest book, my latest New York Times bestseller. And so, yes, go to my website, mkaku.org, mkaku.org, and find out what I've been up to. Well, once again, in this hour, I'm going to answer your emails that have come in. Some of you are, well, kind of shy about having your voice heard on national radio, so you send me emails instead. No problem. One set of emails that I get concerns time travel. We've all seen these science fiction movies, and you have all these mind-twisting paradoxes. How do you resolve them? First of all, is it even possible that we can build a time machine? And second, if so, then how do you resolve all the paradoxes? For example, if you go back in time and meet yourself as a young boy or girl, and you kill yourself, then you just committed suicide in the past. But if you do that, how can you be alive in the present if you just killed yourself in the past? How does that work? Or if you go back into the past to change some historic event that's in the history books, you've changed all of world history, including your own. In other words, maybe you don't even exist to change the past. Well, these are all the time travel paradoxes that appear in the movies, so let's take them apart one by one. First of all, it is even possible to build a time machine? The answer is apparently maybe. That is, Einstein's theory of general relativity allows for time travel. For example, if the universe were to rotate, not expand, but rotate, and you were to go with the flow and go around the universe, you could go backwards in time. You could come back before you left. You could actually rewrite history. This solution of Einstein's equation was found in 1949 by a great mathematician, Kurt Gödel, one of the greatest mathematical logicians of the last 1,000 years. And he studied Einstein's equations and found a solution which allowed for time travel. Well, in Einstein's memoirs, he writes that we can probably dismiss this solution of his equations for physical reasons. In other words, the universe does not rotate. Think about that. The universe expands. It doesn't rotate. So if the universe did rotate, then time travel may indeed be possible. Well, since then, a number of other solutions have been discovered which make time travel possible, the most famous being the wormhole. If you make a hole through space and time, like a subway, traveling from one point to the other underground, if you could do that, then perhaps you could go to a distant point in the universe or a distant point into the past. That is a distinct possibility. However, what's the catch? The catch is you have to have a wormhole. and that requires energies comparable to a black hole. So in other words, only a very advanced civilization can create a time machine. And then the next question is, how do you resolve all the paradoxes of time travel? Well, in quantum mechanics, we think that our universe obeys a timeline that separates the past from the future. That's common sense. However, the timeline can fork into two roads. So in other words, the universe can split into parallel universes, and this is allowed under the quantum theory, which is perhaps the most successful theory of all time. We have seen no deviation at all from the quantum theory ever since it was first proposed in 1925. So, if you have the quantum theory, it means that our timeline can split into two timelines, and again into 3 and 4. So perhaps when you go back in time to meet yourself as a young child, that's not really you. Looks like you, has the same genome as you, but it's you in a different timeline. So if you kill that you in a different timeline, it doesn't really mean that you cease to exist. You still exist, but your timeline twin, your double, has died. Now, this means that you can get all sorts of paradoxes and resolve them one by one using the fact that the timeline can split into two timelines. So the river of time can fork into two rivers. So now let me tell you the granddaddy of all time travel paradoxes and see whether you can figure this one out. This time travel story was concocted by none other than Robert Heinlein himself. Robert Heinlein starts with a girl named Jane. Jane starts off as a baby left at an orphanage in a cradle. Well, the nuns at the orphanage don't know what to do with Jane. They call her Jane because they don't know what else to call her. And Jane grows up as an orphan in this orphanage. But she always wonders, who is my mother, my father? I was left as a foundling on the doorstep of this orphanage. Well, when Jane is a teenager, she falls in love. A handsome guy comes into her life, but it was not meant to be. They argue, and he stomps off, never to be seen again. But it's a sad story, very sad, because Jane is left pregnant and abandoned. So what does Jane do? She checks into a hospital, gives birth to a beautiful baby girl, but it's a very sad story. Somebody that night breaks into the hospital and kidnaps her own baby girl. Well, Jane wakes up the next day horrified. First of all, she was pregnant and abandoned. Then somebody kidnaps her beautiful baby girl, and then it's even worse than that. What could be worse? The doctors find out she's actually a hermaphrodite. And to save her life, they have to change Jane into Jim. Well, find out the conclusion of this mother of all time travel stories after we take a short commercial break. Welcome back to Science Fantastic with Professor Michio Kaku. Once again, you can always get on the show by calling 612-564-8135. But for those of you who are a little bit gun-shy, you can send me an email. mkaku.org is the website, mkaku.org. That's the website. You can find all the books that I've written, 4 New York Times bestsellers, including a host of other books about science. And you can get on Science Fantastic, send us an email, or have your voice heard if you call 612-564-8135. So once again, in this hour, I'm going to answer the backlog of emails that I get. One huge set of emails I get is about robots, about computers, about AI. There's so many shows on TV and in the movies about robots. And what do we have to fear? Or what about the opportunities, given the fact that robots could become one of the main engines of the economy in the future? So what are the pros and cons? That's a question that comes out quite frequently. Well, this also came to the fore because of a debate between Mark Zuckerberg of Facebook and Elon Musk of SpaceX. Mark Zuckerberg says artificial intelligence is good. This will provide jobs. economic benefits. People will be employed by the robotics industry. It'll enrich our country. That says Mark Zuckerberg of Facebook. Elon Musk says, not so fast, not so fast. Let's not be naive. One day they could become dangerous. One day they could replace us. One day they could become an existential risk. So who's right, Zuckerberg or Musk? Well, personally, I think actually both are right to a degree. Zuckerberg is right for the next several decades. For the short term, yes, robots are going to give us new job opportunities. In fact, I think the robotics industry will become bigger than the automobile industry of today. I mean, think about that for a moment. After all, think of all the people employed by the automobile industry. People employed as people who repair cars, service cars, maintain cars, drive cars, use cars. And one day your car will be a robot. So your industry, the automobile industry, will be eaten up by the robotics industry because we'll have people who design robots, repair robots, service robots, make new generations of robots, handle robot accidents. We'll have a whole industry based on robotics. And one day, we do have to realize that Elon Musk is not simply talking out of his head. Yes, they are potentially dangerous. At what point are they dangerous? They are dangerous when they become self-aware. That's not going to happen for many decades to come because robots do not know they are robots. However, one day they'll figure it out. And at that point, they may have an agenda different from our agenda. At that point, hey, let's not be naive about it. They could become dangerous. And when is that going to happen? Well, first of all, our robots today have the intelligence of a cockroach, a bug, a retarded cockroach, a lobotomized retarded cockroach. That's how smart our robots are today. If you put a bug in the middle of the forest, immediately it scurries around, finds shelter, finds food, finds mates. Bugs perform marvelously in the forest. You put our most advanced robot in the forest, and what does it do? It falls over and gets lost. So much for the robot revolution. But, let's not be naive. Computer power keeps growing in sophistication. One day the robots will be smart as a mouse, then as smart as a rat, then as smart as a rabbit, dog, or a cat, and eventually as smart as a monkey. At that point, they are potentially dangerous because monkeys have a very well-defined sense of who they are. They are self-aware. They know they're not humans. Now, dogs, on the other hand, dogs are confused. Dogs think that we are a dog. We're the top dog, and they're the underdog. So you see, dogs have a different way of looking at humans. They think that we're dogs, just like them. That's why they lick us. That's why they follow us, because we're the top dog. Monkeys, they know better. And so when robots are as smart as monkeys, then we have to worry. And when is that going to happen? I don't know. But I think it's probably going to happen toward the end of this century at the rate at which we are creating robots. Now, you may have heard some stories of when robots will become smarter than us very soon. Within the next few years, the next few decades, they're going to become smarter than us. Well, yes and no. You see, smart is more than just computational speed. Because the rate at which robots can process digits, well, at that point, that may exceed our ability to process digits as well. But that's not the point, right? The point is thinking, strategizing, understanding what you're doing. These things are more than just digital transformations. They require very complex motions of many central processors, not just one. Because after all, a digital computer has one CPU, just one CPU, a Pentium chip. Our brain is a parallel processor, processes 100 billion neurons simultaneously, not just one CPU, but 100 billion neurons working in unison. And our brain is not a digital computer at all. It is a learning machine. It is not a digital computer. Digital computers are adding machines. They add 1 million times faster than you, giving you the illusion that they think. Nope, they don't think at all. They just add much faster than us. But let's be honest, one day robots may attain that ability, and at that point, they could be dangerous. What do? I suggest we put a chip in their brain to shut them off if they have murderous thoughts. But then I have another set of questions. What happens if they're smart enough to go around a fail-safe system? If we put a chip in their brain to shut them off, what happens if they're smart enough to remove that chip? Then what are we going to do? Robots are going to become smarter every year. Not dumber, but smarter every year. We are pretty much stagnant in that category. So what happens inevitably, maybe in the next century, when robots exceed us in intelligence? I suggest that at that point, we merge with them. Rather than fight them, merge with them. And that's a possibility because we're now beginning to explore computer-brain interface, which is a subject of my book, The Future of the Mind. So, believe it or not, we can now hook the brain to a computer so that telepathy and telekinesis, things that you see in a movie, are actually possible today. This is something to think about. So, at that point, we may want to become superhuman. Now, you may say to yourself, wait a minute, does this mean that I'm going to be a brain in a vat of liquid connected to a computer, and I'm going to spend my whole life thinking inside a computer? How boring. I don't want to do that. I don't want to have electrodes dangling from my head looking like some kind of freak. I don't want to be like that. So what do we do if we want to merge with computers rather than compete with them? Well, personally, I believe that we should create an avatar. An avatar that is perfect, beautiful, strong, handsome, whatever, with superpowers. And we should use our brain to drive the avatar. So for all intents and purposes, you think you are the avatar. Your brain may actually be in a vat of liquid connected to a computer someplace, but you control a perfect avatar. So you have a perfect body capable of living on any planet, capable of withstanding any gravitational field, any noxious poisonous gases, any dangerous predicament that you may find yourself in. A perfect robot. Think about that for a moment. Now, I believe when people ask me, what will humans look like in the far future? I believe in what I call the caveman or cavewoman principle. You see, we humans haven't changed much for 200,000 years or so. We have the same wants and desires as our ancestors of 200,000 years ago. And what do we want? Well, after our basic needs are satisfied, we want to look good. We want to have the respect of our peers. And that will determine the future, as we will tell you after the break. So let's have a commercial break. And after that, we're going to talk about what humans are going to look like 100, 1,000 years from now. What are we going to look like? Well, you're listening to Science Fantastic. Give us a call at 612-564-8135. And after the break, we're going to talk about dreams, Sigmund Freud. We're going to talk about the future of robotics on Science Fantastic.
This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, I'm going to take your emails and answer them. I have a pile of emails that have been sitting on my desk, and this is for people who are a little bit gun-shy and are hesitant about making a question on national radio. You'd much rather be anonymous. You'd much rather simply send me an email and have the answer read on national radio. So, as I said before the break, we're going to talk about the future of humanity, not just robots. I think that in the next century, that is, in the 22nd century, way in the future, when robots become extremely intelligent and our fail-safe systems, our safety mechanisms all fail, what are we going to do? I say instead of competing with them, why not merge with them? Why not become super powerful, super beautiful, super handsome, capable of living on any planet, capable of withstanding any gravitational field, breathing any kind of noxious atmosphere, superhuman as we explore the universe? And then people ask me the next question, what are we going to look like? Well, when I was a kid, I read comic books like all the other kids on the block. And of course, the human of the future had a gigantic head, a huge head, a tiny, tiny, tiny little body. We were totally bald. And sometimes we were just nothing but a brain in a vat of liquid. And I thought to myself, yuck, who wants to live like that? Who wants to live the rest of your life immortal as a brain swimming in a vat of liquid connected to a computer? And who wants to live with this gigantic head with a tiny, tiny, tiny little body and being completely bald? Who wants to live like that? Well, I have a different point of view. I believe in what I call the caveman or cavewoman principle, the fact that we humans really haven't changed much in 200,000 years. We want to look good. We want to have the admiration of our peers. We want to have a good position in society. That's what we want after our basic needs are taken care of. And so in the future, we'll still look like us. That is, we will enhance ourselves, we'll have superhuman powers, but we're going to look like us, except we'll be beautiful, we'll be handsome, we'll be super strong, capable of all sorts of feats. And if it means that we have to have certain electrodes planted in our head, well, we'll take them off on a hot date. So if we have a hot date that night, we'll take off our implants, we'll take off our helmets that give us these abilities and act normal. Because the caveman principle means that the basic human body is not going to change so much. So when science fiction writers talk about humans looking like some kind of freak, I don't think so. Because if we have tremendous powers of technology and science, why do we want to look like a freak? Why do we want to look like some idiot? Somebody that'll laugh at us? Why do we want to look like that? I think we will pretty much look the same way we are now. And so as I said before, in this century, we'll be pretty much in competition with robots, but we'll be smarter than them in this century. And in the next century after that, we'll probably merge with them. And then another set of questions I get is, well, let's get back down to earth. My job. Will my job be phased out? Or for that matter, your job as a professor, are you going to be on the unemployment line as machines get smarter and smarter? Well, let's talk about this after the break.
Brought to you by Professor Michio Kaku. This is Science Fantastic.
Welcome back to Science Fantastic with Professor Michio Kaku. And Science Fantastic, we take your listener phone calls and also your emails and answer them on national radio. So before the break, we had a question that I get a lot is, what will the jobs of the future look like? Will I be unemployed? And for that matter, will you be unemployed? Well, let's be honest about this. We don't have blacksmiths anymore. We don't have wagon makers anymore, but we don't cry about them. Those jobs are gone. But people switched jobs. They got job training. They became automobile workers and things like that. And so those jobs are still flourishing, the jobs that replace the automobile workers. But now automobile workers are being laid off. And so the question is, what about the next set of jobs to be opened up? Well, I personally believe that the jobs of the future will be those jobs that robots cannot do. So obviously the next question is, what jobs can't robots do? And there's several categories of jobs that robots simply are useless at, and let's talk about them. First of all, jobs that involve human judgment. For example, a lawyer. A lawyer has to argue to a judge, not a robot. A lawyer has to talk to a jury and convince the jury. A lawyer has to master the art of persuasion. All these things robots can't do at all. They don't understand human mores, ethics, and human behavior required to argue a case in court. Now, on the other hand, the paralegal, could be endangered because a paralegal is basically a search engine. Somebody that goes through the law books, tries to analyze each one to find out precedents in the past. And so those jobs could, in fact, be phased out. But jobs that involve counseling, mentoring, jobs that involve arguing a point, things that involve human interactions, they will be around. And so professors, for example, will be around, but for a different reason. In the future, we'll have e-courses. That is, you'll simply wave your hand, and there's a master professor giving you the lesson right there in cyberspace, perhaps in your contact lens. So you blink, and there's your favorite professor giving you your latest lecture in that subject that you're studying. However, that doesn't answer your homework problems. That doesn't mentor you when you want to know your career path. That doesn't give you guidance. And that's where the professor comes in. So the professor is going to be more and more a mentor and less a teacher. Teaching will be done mainly through e-courses, which you can do at home or just by blinking. And, however, mentoring requires a human, somebody who knows your strengths and weaknesses, knows the job market, and they can give you sound personal advice. So jobs involving human kinds of interactions will be around for a long time to come. Also, jobs that require semi-skilled professional skills, like being a plumber, being a gardener, policeman, construction worker, those jobs will still be around. Robots cannot pick up garbage. Robots cannot solve a crime. Robots do not understand how criminals think. Robots do not understand how to fix a broken toilet. Those jobs will be around. But what about the jobs involving mechanical skills? Well, if it's repetitive, they're out the window. I repeat, repetitive jobs, if they can be replaced, will be replaced. So the jobs that will replace them will be jobs involving intellectual capital. More and more, the key buzzword of the job market of the future will be intellectual capital. Capital of the mind rather than capital of the hand. As Tony Blair likes to say, England derives more revenue from rock and roll than the coal mining industry. I mean, think about that for a moment. The Beatles, Elton John, all those rock stars, they generate more income for England than the coal mining industry because music is intellectual capital. Writing a book, singing, writing a song, being an actor. These are things that robots cannot do. Robots cannot write a novel. They can copy, but they can't create new novels that excite the public. And so intellectual capital, those jobs are going to flourish. Now, that doesn't mean you have to be Bill Gates and some kind of high-tech genius. No, that is one form of intellectual capital. But there are many, many other forms of intellectual capital that are going to continue to generate wealth in the future. Well, let's take a short commercial break. Once again, this is Science Fantastic with Professor Michio Kaku. Give us a call at 612-564-8135, and maybe your thoughts will be heard on National Radio. Welcome back to Science Fantastic with Professor Michio Kaku. In this hour, we're taking your email questions. That's right. First of all, if you want to verbally ask a question and perhaps get on National Radio, give us a call at 612-564-8135. Leave your name, call letters of the radio station you're listening to, and the city you're calling from, and then you can ask that question, make that comment, and perhaps you'll be on National Radio. But for some of you who are still a little bit shy about that, you can send me email. My web address is mkaku.org, mkaku.org, and you can send me an email question. And also, while you're on my website, check out my books. I've written 4 New York Times bestsellers. The Future of Humanity is my latest one, talking about the future of the space programs as we go back to the moon, on to Mars, and maybe the asteroid belt and beyond. The Future of the Mind talks about brain-computer interface, how we are now interfacing the human brain with computers, giving us the ability to manipulate exoskeletons, to communicate telepathically, telekinesis, the ability to move objects by the mind. In Physics of the Impossible, I talk about, well, science fiction. I talk about time travel, ray guns, teleportation, all the stuff you see in science fiction movies. And in Physics of the Future, I talk about the next 100 years. What will robots, what will medicine, what will cancer research look like in the next 100 years? Well, once again, in this hour, we're going to answer your listener phone calls. One question I get is about psychology, not just about the mechanics of the brain, but psychology. That is how we think. And when you take a psych course, chances are you learn about Freudian psychology. Freud talked about sex, 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 sex. Well, besides that, he also talked about the unconscious mind, and the fact that consciousness is in three parts. The libido, which is desire, the id, which is your person, you, and your superego, which is your guilty conscience. So, and Freud also said that dreams are the highway by which we understand human thinking. So how has that held up? Now that we have brain scans, now that we have MRIs, now that we can peer right into the living, thinking brain. Well, first of all, a lot of Freudian psychology, I think, is nonsense. It's just pure garbage. However, there are some real nuggets of gold in Freudian psychology. First of all, the unconscious mind. Yep, Freud was right. Much of the activity of the brain is unconscious. If you brain scan the brain, you realize that the conscious brain is just what happens behind your forehead. A thin layer behind your forehead is what we call you, your conscious mind, your self-aware brain. The rest of it is largely unconscious, like the bottom of an iceberg. You're not even aware of the fact that your brain is performing all these calculations, all these functions. You're not even aware of it. You think just behind your forehead. Freud was right on that. Freud was also right in the fact that consciousness has at least three parts. That is a superego, which tells you, can't do that. Your id, which is you, how you view yourself. And your libido, which is desire. Yes, you can see these parts of the brain right there on a brain scan. With the MRI, you can show that the id is your prefrontal cortex right behind your forehead. Your superego is right behind your eyeballs in the orbital frontal cortex. Right behind your eyeballs is your guilty conscious. At the center of the brain is the nucleus accumbens, which is your pleasure center. So yes, indeed, Freud got it right. And then about dreams. Well, Freud thought that in some sense dreams was the royal road to consciousness. Scientists today don't think so, but scientists today can understand a little bit about the dreaming process. First of all, in a brain scan, you can see that several things light up and other things are dark. For example, when you dream, the front part of your brain shuts off and the orbital frontal cortex shuts off. So in other words, your id and your superego shut off. That's why dreams are bizarre. They're crazy because the orbital frontal cortex is in charge of fact-checking. Your fact-checker is your orbital frontal cortex right behind your eyeballs. And they tell you that, something's wrong, something's not quite right. That is shut off. Therefore, the brain is free to roam as it does during a dream. Meanwhile, the center part of the brain is very active, mainly the amygdala, which controls emotion and especially nightmares and fear. That's why many dreams are unpleasant. That's why many dreams are, in fact, nightmares, because that part of the brain lights up when you are dreaming. And then the next question is, can you control your dream? This is called lucid dreaming, and the answer is yes, it is possible. It was once considered folklore to be able to be awake while you dream, but now we see it with brain scans. We can take, for example, a lucid dreamer, put him in an MRI machine, have him dream, and the prefrontal cortex is fully active as the person dreams. So the amygdala lights up, meaning that the person's emotions are activated. But the person's prefrontal cortex also lights up, meaning that he is fully awake while he is dreaming. Think about that for a moment. And it turns out that Buddhist monks centuries ago wrote handbooks about how to do it. Yes, believe it or not, there are handbooks about how to become a lucid dreamer. One, remind yourself just before going to bed that you are going to control your dream. B, have a notebook that records all your dreams. And yes, you too can control your dream. Okay, well, once again, this is Science Fantastic with Professor Michio Kaku. Give us a call at 612-564-8135 and join us every week when we discuss the cutting edge of science on Science Fantastic. Good day.